Hi everyone. This week we've been talking about different types of reactions, and today what we're going to do is we're going to dig in and learn a little bit more about decomposition reactions. So as a reminder, a decomposition reaction is one in which a single compound breaks down into two or more elements or new compounds. So the general form would be that you've got some compound AB breaking down into A plus B. We talked about a couple of examples of these in class together on Monday. And the way that you recognize these decomposition reactions are that they only have one reactant and that they're going to have multiple products. Today we're going to talk about 4 rules for predicting the products of a decomposition reaction. So 4 ways to look at what the reactant is and predict what the products are going to be, and then how to balance those equations. The first rule is that all binary compounds will break down into their individual elements. So when I say a binary compound, remember that prefix bi means 2, so these are going to be compounds containing only 2 elements. So they're going to break down into those individual elements. So we're going to do one example together, and then I'm going to have you try one on your own. So my first example here is silver oxide, Ag2O. All right, and I know that it's binary because it only contains silver and oxygen. So if I wanted to show the decomposition of silver oxide, I would want to show that my products are going to be silver and oxygen. All right, I'm not quite done yet because I have to then check and see if either of these elements are what we call those diatomic elements. So we talked about diatomic elements a little bit a couple of weeks ago. But diatomic elements are elements that cannot exist on their own, and instead they travel in pairs. And so you'll want to remember the sentence, "All bring cookies for our new home," and that would represent iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. And so I can see that one of those elements that I named is oxygen, so I can't just write an O here. Anytime I write O by itself, it's got to be diatomic, so it's got to be O2. So our 2 products here are silver and oxygen. All right. Now, the last step, anytime I'm writing out a chemical equation, is to make sure that it's balanced. I can see that I've got 2 silvers here, so I want to put a 2 in front of the silver to balance that. Then I can look and see that I've got 1 oxygen here and 2 oxygens over here. So that means I'm going to have to put a 2 in front of my silver oxide. And then you'll notice that now I've thrown off the silvers again, so now I've got 2 times 2 or 4 silvers. So I'm going to change this to a 4, and my reaction is balanced. All right, now I want you to take a second, pause the video, and see if you can predict the products for the decomposition of sodium chloride. All right, so for sodium chloride, this is another binary compound only containing 2 elements. So it's going to break down into sodium, Na, plus chlorine, Cl. Just like oxygen, chlorine is one of those 7 diatomic elements. So when we write Cl, we can't leave it by itself. We've got to put this little subscript 2, so it's got to be Cl2. All right, so our 2 products are sodium and chlorine, and then we need to balance the equation by putting a 2 in front of the sodium chloride and a 2 in front of the sodium here. Rule number 2 is that all carbonates break down to the metal oxide and carbon dioxide. We recognize carbonates because they contain that polyatomic ion carbonate, which is CO3. So this is going to be any compound that starts with some kind of cation, some kind of metal, and ends with CO3, which is carbonate. So when I say the metal oxide, you want to figure out what in your compound is the metal. And then oxide means it's going to come from oxygen. All right, so the metal oxide of zinc carbonate is going to be zinc oxide. So we'll have to figure out the formula for zinc oxide. And then our second product is always going to be carbon dioxide. So let's do this one together. All right, so we've got zinc carbonate. And we know that because it's a carbonate, we want to figure out the compound that forms that's called zinc oxide. So we have to think back to a little bit earlier in the year and remember that we need to cross down the charges to figure out the formula. So zinc is a transition metal, but zinc always has the same charge, and it's always going to have a charge of +2. Oxygen, in group 16 on the periodic table, has 6 valence electrons. It's going to gain 2 more to get a charge of -2. And so when we cross down our charges here, we're going to get Zn2O2, but then that 2 and the 2 can reduce down to 1 and 1. So our formula for zinc oxide is ZnO. Then our second product is going to be carbon dioxide. So this is a covalent compound. So it's going to have 1 carbon and 2 oxygens, carbon dioxide. So these are going to be our 2 products. And then we just want to check and see if our reaction is balanced. So we've got 1 zinc on each side, 1 carbon on each side, and then over here we've got 3 oxygens, and over here we've got 1 plus 2 or 3 oxygens. So this one is already balanced. All right, I want you to see if you can predict the products for the decomposition of sodium carbonate. So follow the same set of rules, pause the video, and when you're ready, check the answer. All right, so if we have sodium carbonate here, we know that our metal is sodium. So we want to figure out the formula for sodium oxide, and then our other product will be carbon dioxide. All right, so we want to look at the charge on sodium and the charge on oxygen. So sodium is in group 1 on the periodic table, so that's got a +1 charge. Oxygen is in group 16 again, so it's got a -2 charge. And when you cross down the charges, the formula for sodium oxide is Na2O. So sodium oxide has this formula, and then our other product again is going to be carbon dioxide. Now, if we check our balancing here, we can see that we've got 2 sodiums on each side, 1 carbon, and 3 oxygens on both sides. So this one also is already balanced. Rule number 3 is that chlorates will break down to the metal chloride plus oxygen. All right, so chlorate, remember the polyatomic ion is ClO3 with a -1 charge. So anytime you see this group ClO3, that's a chlorate. And the decomposition will be the metal chloride and oxygen. So our metal here is nickel. Chloride means it's going to be paired with chlorine. And then our other product is going to be oxygen. And because oxygen is one of those diatomic elements, it's always going to be O2. So we're going to figure out the products and then balance the reaction. So if we've got nickel chlorate, we're going to do something similar to what we did to figure out the formula for the metal oxide. So our metal is nickel here. And I can tell because I've got 2 chlorates here and each chlorate has a -1 charge that my nickel had to have a +2 charge to balance out those 2 chlorates. Now, chloride means just chlorine. That IDE ending means it's just a single element. And chlorine is in group 17, so that one's got a -1 charge. So when I cross down my charges here, I'm going to get the formula for nickel chloride as NiCl2. All right, so this is my metal chloride, nickel chloride. And then my other product is always going to be oxygen, which is diatomic. So it's going to be that O2 here. All right, my last step is to balance this equation. So if I look here, I've got 1 nickel and 1 nickel. I've got 2 chlorines and 2 chlorines. And then I've got 3 times 2 or 6 oxygens. So I need to balance this so that I've got 6 oxygens over here. So I'm going to put a coefficient of 3. All right, I want you to try to predict the products for the decomposition of potassium chlorate and then balance the equation. All right, so if we look at potassium chlorate here, our metal is potassium. So for our first decomposition product, we're looking for the formula for potassium chloride. So if we take potassium, that's in group 1, so it's got a +1 charge. Chlorine, again, in group 7 has a -1 charge. So when we cross down our charges here, we get that the formula for potassium chloride is KCl. And then again, our second product is always going to be oxygen. And because oxygen is diatomic, it's going to be O2. All right, now to balance this equation, first we want to kind of look at the oxygens, because on our reactant side we had 3, and on our product side we had 2. And so to make 2 and 3 equal, we want to end up with 6 oxygens on both sides. So we put a 2 in front of potassium chlorate and a 3 in front of the oxygen, so that we've got 6 oxygens on both sides. Adding this 2 over here on the reactant side means we now have 2 potassiums and 2 chlorines. So we want to put a 2 in front of the KCl as well. Our last rule is that hydroxides are going to break down into the metal oxide plus water. All right, so hydroxides are compounds that contain OH, right? So this is the polyatomic ion hydroxide. So just like we did for the carbonates, those are going to break down into the metal oxide, so the metal paired with oxygen. And then the other product here is going to be water, H2O. All right, so if we look at our formula for FeOH3, this is iron 3 hydroxide. So the metal is iron. So we want to figure out the formula for iron 3 oxide, and then water will be our other product. So we've got FeOH3. And I know that this is iron 3 because hydroxide has a -1 charge, and there are 3 of them. So I have to have a charge of +3 on my iron to balance out that -3 from those 3 hydroxides. Okay, so I'm going to do the same thing that I've been doing. I just figured out that iron has to have a +3 charge, and that oxygen in group 16 has to have a -2 charge. So iron 3 oxide is going to have the chemical formula Fe2O3. All right, so Fe2O3, and then our other product is going to be water. All right, and then the last thing that we need to do is balance this equation. All right, so the first thing right off the bat that I notice is that I've got 2 irons over here. So I'm going to put a 2 in front of my iron 3 hydroxide. When I do that, that gives me 3 times 2, or 6 hydrogens. And I've got 2 hydrogens over here, so I'm going to put a 3 in front of the H2O. And then over here I've got 3 times 2, or 6 oxygens. And on my product side I've got 3 plus another 3 to give me 6 oxygens over here. So that equation is balanced. All right, so see if you can predict the products and balance the reaction for the decomposition of copper 2 hydroxide. All right, so copper 2 hydroxide. First of all, I want to figure out the metal oxide. So the metal here is copper. So we want to see how copper goes together with oxygen. Now this hydroxide has a -1 charge, and there's 2 of them. So the copper must have a +2 charge. So copper with a +2 charge, oxygen with a -2 charge, you would get Cu2O2, and then those 2's would reduce to 1's, and so your formula for copper 2 oxide is just CuO. And then again, our second product is going to be water, H2O. Now, if we look to balance this equation, we can see that we've got 1 copper on each side, we've got 2 oxygens on the reactant side, and then 1, 2 on the product side. Then I've got 2 hydrogens and 2 hydrogens. So this one is already balanced.